All right, so this is Unit 4, Day 5, and we're just kind of reviewing all the topics that we need for our test. So this warm-up is kind of just to go over some of the bigger topics that we've seen and kind of touch on some of that before we move into our review. So we'll just start going over these questions together. I would encourage you to try them on your own to see how many you can do by yourself, but we'll go over them together so that we can get that practice in. So it says the average heart rate for adults is 74 beats per minute with a standard deviation of 6. It is said that having a heart rate of 70 or below lowers your risk of a heart attack. If a person was randomly selected, what is the probability their heart rate is below 70? So since we're just asking one person, this goes back to what we did in Unit 3 with our normal distribution. Our mean is 74, and we're looking for 70 or below. So we're looking for all of this down here. So I'm going to run a normal CDF. My lower bound, since I'm going all the way down here to my negative numbers, to as low as I can go, I do negative 1e to the 99. My upper bound in my shaded region was 70, right? This is the value I was looking for. My mean is 74, and my standard deviation is 6. So this is what I'll type into my calculator to solve. So we'll go ahead and hit stat, or second vars, my apologies, second vars and normal CDF. My lower bound, negative 1e to the 99. My upper bound is 70. My mean is 74, and my standard deviation is 6. So I get that my probability is 0.2525 when I round that. So the next question says the average heart rate for adults is 74 beats per minute. It is said that having a heart rate, all the same stuff, but it asks if a group of 15 people were randomly selected, what is the probability that their mean heart rate is below 70? So same scenario, we're just looking at a group of 15 people. So we talked about this with our central limit theorem. That's going to affect, it does not affect our mean. Sample means and population means are the same, but it does in fact affect our standard deviation. So we're going to have our normal CDF. Our mean is going to stay the same, but our standard deviation is going to be divided by the square root of our n value. So when I solve this, I will divide just that last value by the square root of 15 and compute the same type of probability. So I get that my probability is now 0.0049. So a less than 1% chance. Remember, the more people that you ask, the closer your sample means come. The more your sample means get to your population means, so you shouldn't see much deviation as you do if you're just asking one person. All right, so I want to compute the confidence interval for the following data. So it's just given me what it wants me to type into my calculator. Since it told me a mean and a standard deviation, that means I know I'm running a t interval. So I'll go to stat, go over to test, right? To run my t interval, I go stat over to test, down to t interval. My mean is 27.4, my standard deviation 4.62, my n value 56, and it wants me to start with a 90% confidence interval. So I get 26.367, 28.433. So now we're going to run the same test. We're assuming all of our conditions are met. So we're just practicing running this interval and looking at the difference when we run it with a different confidence level. So when I run it at 95%, I get 26163 to 28637. And then I'm going to do the same thing. Stat, go over to test to t interval, and then I'm just changing this to 99. So I get that this is 25753 to 29047. So this is just practice running confidence intervals with different percentages. And what we notice about these intervals is that the higher our percentages get, right? The higher these confidence levels become, the wider our intervals are. Right? Here it was 26.3 to 28.4. It got a little wider on this one and even more wide on this one. That's because if I'm claiming to be more confident, I'm going to cast a wider net of possible values to make sure that I can say with certainty that 99% confidence that my number is in this interval. I'm going to need to make my interval a little bit wider to ensure that that number is actually there. So the higher you're looking for the higher your confidence interval is, the wider your interval becomes to make room for that extra confidence. All right. So then if we look at number 4, a company believes their customer satisfaction is around 83%. How many people would they need to survey to be 95% confident that that percentage with a margin of error of 2%? So I'm looking for the sample size that I would need. So I will give you these formulas when we take our test. When we're looking at, we're looking at a percentage here. We have 2 possible N values that we're looking at. One of them is where your point estimate is known, and then one is where your point estimate is not known. So because they think it's 0.83%, we're going to say that our point estimate is known at 83%. So our formula, when we think our point estimate is known, times P times Q over E squared. So Z, remember, is that Z value you get for each confidence level, that critical value. So for a 95% confidence critical value, we use 1.96. Again, we said our P value here was going to be 0.83. We're using that as our point estimate. So if P is 0.83, then Q is the rest of that to make up an entire percent or 100%. So remember, Q is just 1 minus P. So 0.1 minus 0.83 would give me 0.16. So Q is going to be 0.16. And then I want a margin of error of 2%. So that's 0.02 squared. We're going to turn that percent into a decimal. So then we just type this into our calculator, and our calculator will tell us what our N value would need to be. So if I say 1.96 squared times 0.83 times 0.16, and then I'm going to divide that value by 0.02 squared, I get 1,275.41. And in this case, we always have to round up in order to be sure that we asked enough people, right? And if we need 0.4 of a customer, then 1,275 is not enough. So we need to ask 1,276 to be sure that we have enough in our interval. So the number 5 says this: if a company did not have any idea what their satisfaction rating was, but wanted the same results, how many people would they need to survey? So this is that when N is, or when our point estimate is unknown. The only thing that changes in our equation is we can't use P and we can't use Q. So in place of that, they ask us to use 0.25. So again, nothing is really, this part's not changing because we're still looking to be 95% confident. So our Z value is still 1.96. And then we'll do 0.25 and 0.202 as my margin of error. So 1.96 squared times 0.25 and then divide by 0.02 squared. Tells me that I need to ask, and this actually gets, sorry, I'll do that all again. 1.96 squared times 0.25. And then I'm going to divide by 0.02 squared. And I get 2,401. And because it's not a decimal, we don't need to round up. Asking exactly 2,401 customers will suffice to get us the sample mean that we're looking for. So these are the two equations we use when we're talking about a proportion or our one prop Z intervals. If we look at this example, the tutor doctor claims that he can increase Increase your SAT score by to mean of 200 points and a standard deviation of 35. So because, again, we're looking at standard deviation, this would be our T interval. And we have a different equation for that. And that one, our equation is N is Z times S over E all squared. So Z is that same thing. So since I want to be 90% confident, our critical value table tells us that's 1.645. Our standard deviation here is 35. Our E value, this is not a percentage. I just want to be a margin of error of 10 points. So our E value is 10. It's different for our T intervals than our one prop Z intervals, because we're not talking about percentages or proportions. We're talking about an actual number that we're calculating. So we'll just use the value 10. So when I plug that into my calculator, 1.645 times 35 divided by 10, and then I'll square that final answer. I get 33.115, which again, we have to round up to make sure we have enough people, right? If I'm supposed to ask 33.1 people, I can't ask a 0.1 of a person. So we've got to round up to 34. So we've got to ask 34 students if their score increased to know what the true sample mean is, or to confirm that sample mean. So that's just the intro to our review. We're going to review more in our review packet and spend some more time reviewing in class. But this was just kind of an intro to kind of the main points that we'll see on our test next class.